Good morning, everybody, and welcome to another week where we are continuing our graphing discussion, but we are close to the end. Let's see what we are talking about for 2 days. If we remember our graphing steps, just open the YouTube chat just in case someone has a question. I can see it. Perfect, thank you. Graphing steps, it's always good to remember them. You should by now. We have our warm-up step where we may find the y-intercept, see if what kind of function I'm working with, what do I expect, if you expect anything. Just getting into the right mindset. Then we had our asymptotic behavior. Ooh, that's an ugly H. Where we analyze the function and we see what's the long-term behavior, are there any asymptotes, so on. We might not know the behavior close to the asymptotes perfectly, but when we get to increasing, decreasing behavior, that asymptotic behavior is sort of completely figured out, and you can pick the arrows according to where it's increasing and decreasing. So I don't worry about fully answering the asymptotic behavior of the graph close to the asymptotes. I just want to know if there are asymptotes. What's the long-term behavior, and so on. So for step 3, we analyze the derivative, see where's the function going up, where's the function going down, critical points, and so on. Then we looked at concavity, analyzing the second derivative. How is the graph bending? Where is it bending up? Where is it bending down? And so on. Now, if you have all this information, or if you're given this information, either way, there is a 5th step where I want to put all of it together and graph the function. And that's something that's easily overlooked and not given enough attention to in books. Really, all the books I've seen, they don't just isolate this last step, that regardless of where the information comes from, I figured it all out by doing all these steps, or it's just given. Can I put everything together and see what the graph looks like? Can I put all the pieces of the puzzle together? That's not that easy. So I want to devote some time to just that step, because there is a midterm question exactly like this, but it's also very important to be able to put the pieces together and see what the puzzle looks like. So I don't really know. We're just going to go through some problems. Actually, let me do it on a new page. Go through some problems, see if there are any questions, see if there's interesting things I can see in preparation for a midterm question, if nothing else. So let's just look at whoopsie, eraser mode randomly. Problem 9.4. We're looking at, well, I might as well just do number 1. So I'll just show you what it looks like, but I'll copy the information. So it's at the very bottom of page 60 where the problem number starts. So determine a rough graph of the function with the following information. Sometimes they give you all the information you need. Sometimes they leave some stuff out in terms of specific y values so that you can focus on the shape. And you can pick a y value that gives you a nice curve, and we'll see that as we go. So we have some information here. Let's zoom in a little bit more. Oh, that's too much. About the function, about its long-term behavior, about some derivatives, some second derivative values, and then the most important parts of the table. And we'll duplicate this. And I suggest that if you don't like the look of this, to maybe make it look more familiar. So I'm just going to move this off to the side, but I am looking at it. And let's copy it to maybe make it look a little bit more familiar. To see if, so let's see, can we do anything in step 1? Do they give me a y-intercept? They give me nothing. All right, so nothing. That's nice. Great start. But step 1 was an optional step anyway. So step 2, asymptotic behavior. They tell me f of 1 is undefined. They tell me the limit. So yeah, we're wasting a little bit of time copying these over, but we have 2 days for just this. I think we're going to be okay. And maybe I want to make it look more familiar. They tell me the limit. Oops, was it a negative infinity? Yeah, that's a negative infinity over here. Negative infinity is a 2. And the rest is derivative information, which is not a part of step 1. The tables that they give me, not a part of step 2, rather. Okay, so let's perhaps, what should we do here? I kind of want to put the graph up here. Why not? Pick a straight line tools. No. What was that? That was supposed to be a straight line. Let's put it up here and see. Okay, so this now means, now for our kinds of functions, having the function be undefined will indicate that there is potentially a vertical asymptote there. Now in general, I know that's not necessarily the case, but we're not looking at functions that have weird things and all kinds of technicalities. When the function is undefined, it will be a vertical asymptote. I don't know how it, for this kind of question, I don't know exactly how it's going to behave close to that vertical asymptote, but I know there is one. So at this stage, maybe I'll leave my arrows as options. Just like I would normally, nothing is changing. I just don't have to do all the work. I can skip right to the graphing step. Horizontal asymptote? Yes, because these infinite limits exist. Equal to 2. Let's put 2 maybe a little higher. I don't know what's coming up, right? They don't really give me y values, so I seem to be free to choose them. So that's at 2. I don't know how it approaches that line, but I know it's on both sides. Both limits have a value of 2. Okay, so I kind of like this question because I don't have to do any of the work. They give me the answer. I just have to visualize it. It's kind of nice. So just don't get confused with these kinds of questions. If it says something's undefined, they're really saying it's a vertical asymptote, just to keep things nice and simple. Okay, so that's what I have. They don't give me a y-intercept, maybe to make the graph nice and easy to work with. Sometimes it's hard. If they tell me that's a y-intercept, sometimes you get a little wobbly trying to get through that, because you have that target point that you have to get through, and that makes your graph wrong. So they sometimes leave out some y values just to make it easy to focus on the shape of the graph more than anything else. So don't worry if you feel something's missing in terms of a specific y value. That's done on purpose. So next, and again, we have 2 days for this. Please feel free to interrupt me with questions at any stage. Then they tell me some derivative information. So they're essentially giving me the important parts of the table. There is some stuff happening that I don't see, and then I get to see the end result of the sign of the derivative. And it's broken up at 1 and at 2, and that's it. Notice that, I'll show you this again here. Notice that here, they're not giving me the full sentences. I think this is a little bit nicer, actually. 1 is not included because the function is undefined there, right? So that 1 in any sentence that you may want to write, the x equal to 1 is excluded. But that's the only one where it's undefined. 2 is a square bracket if you were to write those sentences, which you don't have to, of course. So I have a minus, and then a minus, and then a minus. So it's all minuses. Okay. I also want to know what happens at those x values, right? So that's where they give me this middle box. The derivative at 1 is undefined. Derivative at 2 is 0. So I can put that right in my table. Derivative 1, undefined. Derivative of 2, 0. So now, this is really all I need. I have a negative slope line, then some bad stuff's happening, which I know is a vertical asymptote, then a negative slope line again. Negative slope line, 0 slope, so horizontal asymptote, and then, no, not negative. Not positive, but negative again. Okay. So different things are happening, but at the very least, let's at least refine our asymptote arrows next. So I remember everything's decreasing everywhere. So if everything is decreasing, it can't be this top arrow working left to right for the horizontal asymptote. It can't be that top arrow because then it would go up. It has to go decreasing down, decreasing to the vertical asymptote. So it can't be the top arrow of those two. That's increasing. Decreasing down from that from that vertical asymptote. Can't be the bottom one then. Decreasing down towards the horizontal asymptote. Can't be the bottom arrow. So again, let me show it on the same screen here. By waiting for step 3, increasing, decreasing behavior, the choice of arrows close to asymptotes, that choice is as easy as it can possibly be. There's no extra work needed. Whereas when I do it in step 2, or try to, it's not impossible, but it's unnecessary work when step 3 is going to give me which arrows are the correct ones anyway, as sort of a side effect. It doesn't even try to answer that question. I just get it for free. So that's why at step 2, I didn't care about having choices for arrows, knowing step 3 is going to resolve that. Okay. So now, let me get a picture here. It can be tricky. I don't want to go too fast. And to be honest, I don't remember the answers for these. I have no idea. I'm doing it with you as if it's for the first time. I don't remember these at all. And some of them I've never done. So it's nice to sort of discover it together and see where are the sticky points that I need to watch out for. So I'm going downhill all the time. Though at x equal to 2, I have a 0 slope. Okay, so x equal to 2. Now they've given me the freedom to choose a y value that suits my preferences. They don't tell me the y value. So it could be anything, but not anything. It can't sit over here, because then how am I going to get to my horizontal asymptote without increasing? So there are some restrictions on the y value to fit with all the other information. That point has to be somewhere over here, right? let's just put it there temporarily. What happens there? It goes down into a horizontal tangent and then down again, which fits with everything else. So I'll just put a little line there, remembering that's a horizontal asymptote. So I'm thinking it's probably going to bend in some way, right? I don't know. Now, because I've never done these, there might be a typo somewhere in some of them, but let's explore that together. Let us see. And then, before I get to 2 around the asymptote, it seems like I'm just going to go down somehow, but we'll see if there's a change in the bend. So right now the picture is forming. It's not too bad. Again, let me know if you have any questions as we go. Picture's not quite finished, right? I need to know step 4. So let's see what that gives us. So from that, there's a table as well. They give me the important parts of the table. Oopsie. I don't see the pieces of the function. I just see the end result. And that table is split into x equal to 1, 2, and 4. And it gets a minus, a plus, a minus, a plus. Then I also want to know what happens to this second derivative on those x values. They tell me 1 is undefined, 2 and 4 are both 0. All right. 1 is undefined, 2 and 4 are both 0. So it definitely helps me to make it look more familiar, to put those zeros and crosses and stuff on it, even though it's not in the question. It's separate in the question, making this table look a little less familiar. Put it on top. Put it on those lines, like I'm used to doing. Okay. So that means I'm bending down, up, down, up. Okay. Okay, so it's hard to move a little up and down, but so up to x equal to 1, I'm concave down. I'm bending down, which is what I thought. It fits with how I'm supposed to behave close to the asymptote. So I can fill in that piece and be done with the left side. And it seems like the right side, of course, I didn't leave a lot of space. The right side has more interesting things. Whoa, why that wobble? Why? I'm going to blame my hardware because, of course, it's never me. I'm never at fault. I don't make mistakes. There we go. So at least that part is done. Now there are some more interesting things happening here. And of course, I left not a lot of space to do that. So let's see if I can zoom in. So what's happening here? Well, something's happening at 4 as well. Let's put 4 over here. And let's just clean up the space. I didn't look ahead, so I didn't leave a lot of space for myself. But let's just work with what we got here. So I know something's happening at 2 and something's happening at 4. Let's just put them randomly like that. They have to go downwards to the horizontal asymptote. How much space you give yourself? No, who cares about that? Now I have to remember, these things are in different spaces. I'm going to have to move up and down, so I have to remember. 1 to 2, I'm bending up, then down, then up. Up, down, up. So I'm coming from high up. Whoopsie. Of course, horizontal asymptote here. Asymptote. Horizontal tangent at x equal to 2. So maybe right to left drawing is a little easier. Then I'm going to bend down. Why? Let's try it this way. Whee! Oh, sound effects help. I see. That's not a vertical tangent or anything. It just has a random angled slope, but it changes in the bend to up again. Like that. There we go. That's not so bad. I just didn't give myself a lot of space. Unfortunately, I didn't know. Where the given space here is a little bit better, right? Some better spacing. All right. That wasn't bad at all. It needs more practice than some people think. So let us, no, that one, no. Let's do another one, see what we get. Let's go to, why am I writing so big? That's better. Problem 9.4, let's just do the next one, number 2. Why not? I don't know which ones are good and bad, they're just questions. Now I have the graph spacing at the next page, so I just need to focus on that. All right, so let's see. So many people, they struggle because they want to know what kind of function is it. They want to see the function. It's a little bit of a challenge in its own to not have that luxury to analyze the function, to see the function. I just have to use this information. And that's all I have. So let's see. Warm-up step, yeah, there's a little bit. I can have a y-intercept because they tell me f of 0 is -3. So this one gives me some function values. It also gives me some x values, x-intercepts. But I'll remember that for later. I'll just write them down so I don't forget them. Then I get to step 2, asymptotic behavior. They give me some limits. Far to the right, -infinity. Far to the left, -infinity. All right. So no horizontal asymptotes. Nothing's undefined. So no vertical asymptotes. Okay, that's all good news. This makes my life easier. Or more difficult, I don't know. Maybe you like asymptotes, but I have none of them in this case. So let's see what step 3 gives me. So I did the first 2 boxes. They give me some points. Long-term behavior. No asymptotes. Nothing. So I'm sort of thinking, yeah, this might be some sort of polynomial, right? I don't know what it is. They saved me that trouble, thankfully. But I'm thinking maybe some polynomial. Doesn't have any asymptotic features. So now I'm in the increasing decreasing behavior step, and I need to see that table. So I like to copy the table, make it look more familiar. So let's do that. There's my number line. They don't show me the detail, but they tell me I need to split this up into, according to -3, 1, and 4. All right. So I get a plus, a minus, a plus, a minus. Just copying it over. Then they tell me that the first derivative at -3 is 0, at 1 is 0, and at 4 is 0. That seems very polynomial-like to me. No asymptotes, just horizontal tangent lines. So I have a positive slope, horizontal tangent, negative slope. Negative slope, horizontal tangent, positive slope, positive, horizontal, negative. All right, that seems pretty easy. Do they give me any y values? Yeah, they give me this one is y equals 0, this one y equals 0. They don't tell me what happens at 1. Maybe for convenience of graphing it. Who knows? All right, so that's what we have. So we have a lot. We didn't have that much from step 2, so I didn't bother graphing it. But maybe now, definitely let's graph it. Hopefully I'm giving myself enough space in the areas where it matters. Who knows? So I'm going far to the left and far to the right down for both. That came out of step 2. I have a y-intercept at -3. Let's just put it randomly over here. I don't know. We might have to adjust it. If I need more space there, I can move it down. I have an x-intercept, -3 and 4. That's not super, this is important, but not super important. Luckily, it lines up with where the critical points are. -3, 1, and 4. Okay, so let's give me some space here. Let's say -3 is over there. I know that's an x-intercept anyway. 1, maybe a little closer. And 4 maybe over there, and that's an x-intercept as well. I don't know what the y value is at x equal to 1. Okay, so the step 3 information tells me that I'm making a little crest as I pass through -3. At 1, don't know. I'm making a little cup, which if I'm going to go down through this y-intercept, it's going to have to sit below it. So I'm going to put that point somewhere over here. And remember what happens there. Then at 4, we're making a little crest again. That does fit with the long-term behavior that I got out of step 2, that they're both going down, far to the left and right. So everything seems good so far. I'm increasing from 1 to 4, decreasing down, increasing all the way to -3. Everything seems to work. So far, so good. All right. Now I just need step 4 to tell me how this guy bends. And luckily I have some space. Squeeze it in. So I'm looking at the question. That's where I'm getting all this, of course. Second derivative. I need to split it up at -1 and 3. That's a 3. Why are these lines so long? I don't need them to be that long. Alrighty. Then I have a negative, a positive, a negative. And they tell me that second derivative values, -1 and 3, they're both 0, which for a polynomial, they would be. If the first derivative is 0 in a polynomial, the second derivative is going to be as well. And I'm thinking polynomial, definitely. So I'm concave down, concave up, concave down. Does that fit? Oh, so at -1, something interesting is happening. An inflection point is happening. Now I'm just going to temporarily put it here. It might not be a convenient position for my graphing, but we just have to have a point because they don't tell me the y value. I have the flexibility to make it convenient for my graph. So I don't struggle. If I have a specific point that they tell me, I might wobble trying to get through that point, and then it's not right anymore. It needs to all be smooth. And then a 3. Oh, 3. Let's put 3 over here. These are all different. Inflection point, let's put it over here. These are inflection points, and I could choose the y value. So I'm bending down through this point, then bending up to that point, then changing, bending down. So everything seems to fit. Now I just have to make the graph pretty. So let's get through to our first inflection point. Clear all the temporary stuff that I did to help me remember. I'm going to try and hit that point, but if it's very inconvenient, I'm not going to. So I know there's a horizontal tangent here, so I'm just going to go wee. Sound effects definitely help a lot. This angle is weird for me on the tablet. Can't see my hand. I'm not writing on the screen. I'm writing on my table and looking at the screen, which is weird. I try to get that line. Sometimes draw it in little bits. Still looks smooth. I'm going to take it as a success. Now, what often happens is I run into trouble when I try and hit a y-intercept. But I can make this scale whatever I want. No one tells me what to do. I am going to just focus on my graph and then say, oh, that's -3 right there. Easy. It's not always that easy, but that's what I'm going to do. And no one can stop me. Now I have a horizontal tangent here trying to hit that inflection point. Just try and be as smooth as you can be and bend correctly. And if you need to adjust the scale a little bit to suit your needs, well, I'm labeling everything. It's totally fine. Then I have to get from here to this horizontal tangent. Drawing-wise, it helps me to go from the horizontal tangent. Whether that's left to right or right to left doesn't matter. But when I speak, I always talk as if I'm going left to right, of course. And then, let's hit some nice sound effects. Horizontal tangent down. Whee! Whoa, that sound effects did not help me there. Whee! Let's just stop there. Call it a day. It definitely bends down. I don't know how fast. Just whatever's comfortable. Look at that pretty graph. Zoom out a touch. That's too much. Don't zoom out that much. There we go. There we go. Not too bad at all. But it's maybe nice and relaxing to just sit back, watch me do it. This will be a question in the midterm. You have to be able to do it. Not this specific one, but this kind of question. There will be a question on step 2. There will be a separate question on step 3. Separate question on step 4. Separate question on step 5. And in that way I can mix up the functions. You're not going to do the whole thing from start to finish in a test, because then if I mess something up early, everything else gets messed up too. And for a test, that's a bad idea. But for practicing, it's different. So we are practicing the last step where all the information, asymptotic behavior, increasing, decreasing functions, concavity has been done. Either maybe you've done it, someone else gives it to you, and we just have to put everything together to graph the function. It's 9.4, number 3. We could jump to another one, but I like this one. Okay, so whether you have it in front of you or not, the first part is not difficult. Warm-up is non-existent really, because I don't know the type of function I'm working with here, but I can find the y-intercept that they give me because they tell me f of 0 is 0. Then when I come to step 2, now I don't have to number all this, but it makes it feel familiar. the limits, long-term behavior limits, far to the right, negative infinity, far to the left, also negative infinity. So nothing interesting in terms of asymptotes. We'll wait for something more before we start our graph. And then next, we have the results of the first derivative table that comes in step 3. So I'm just going to copy that over. Let's do it over here. So let me move up a little bit. Our number line is split up at, -2, 0, and 3. Now I don't see all the components, but they combine to give me the first derivative as positive in this interval, negative, positive, negative. And then they tell me the derivative at -2 is 0. Derivative at 3 is 0. And the derivative at 0 is undefined. So I have a slope line going up, horizontal asymptote, down, horizontal tangent line, and then going down, down, bad things happening, then up, up slope, horizontal tangent, down slope. Okay, that's good information. Let's get a graph going here to see what we have. Y and X. So we know we're going down on either side far once all the ups and downs are done. So something happens at -2. Let's put -2 over there. Something's happening at 0, and I know there's a y-intercept at 0 already. Something's happening at 3. I'm going up, increasing to a top turning point, then down to 0. So the top turning point has to be somewhere above the x-axis. I'll put it over there. Then I'm coming down towards 0 and then back up away from it. A turning point at 3. They don't tell me the y values, so I have the freedom to just position it in a comfortable place. But it has to be above the x-axis. There's no other way, because I'm going up from 0 to it and then down to -infinity eventually. And what's happening at this 0? Well, the first derivative does not exist. The function does. That is a vertical tangent line. So I just put something there to remind myself what is happening. Horizontal tangents at the left and right one, vertical tangent in the middle. All right. Now I just want to confirm how the graph bends, and that's step 4. So let's do that. Squeeze it in here. Well, they tell me, and I'm just copying it from the question, that the number line split up at 0 and at 5, and the second derivative has signs negative, negative, positive. At 0, the second derivative is undefined. At 5, the second derivative is 0. So I'm bending down, bending down, bending up. All right, let's see if that fits what I have so far. And it certainly does. I am bending down through the turning point at -2 to 0. So let's fill that in. Let's do it in sections, right? Let's get rid of all my reminder lines here. Don't want to draw on top of it. Want to make it nice and pretty. So I have a turning point here, horizontal and down. Then this section is where I struggle to draw nicely because I cannot see my hand. That is my excuse, and I'm sticking with it. Yep, I'm trying to aim for the origin, but I'm turning too fast. Yeah, it's a little wobbly. Gotta have some fun with it. Let me just get that curvature here a little bit better. We just want to have the idea, right? It's close. We don't have to be professional artists here. Then I'm still bending down from 0 all the way through this turning point to 5 apparently. So let's at least do this bit. Oopsie, not eraser mode. Going vertically up to this turning point, which is a little easier to hit. So something's happening at 5. And that something is an inflection point. It's bending down. Let's put 5 over here. Now I don't know where that is. They don't give me any indication of a Y value, so who knows? It could be way down here, could be higher. I don't know. Let's put it over there. Something convenient. So I'm gonna bend down through that. Let me maybe put it a little higher, just for convenience. They don't specify, so I'm gonna put it in a way where I don't run the risk of accidentally making it a vertical tangent or anything, right? It's just bending down to that point. It has a slope, everything's good, and then bending up, whee, like so. So I have an inflection point over here. I have a critical point over here and the y-intercept and over there, and everything fits together. That is much better. Let me just check the chat in YouTube, see if there are any questions. But let me know if there are any questions. It's a little bit more interesting, And it's a challenge in its own to put all the information together. It's something that I know people overlook, and you shouldn't. And to help you, I will put a question like this in our next midterm. So your efforts to practice this are not wasted. All right.